Hi everyone, this is Madhav, again talking about the 0 to ML series from What's AI. We are still doing the second step to set up for running code in Python. Now, again, if you're feeling confused, there is always the option of going to kaggle.com. All of this setup is done for you. If you still want to, learn these tools, you're feeling like in a good space, you are going to need them as any kind of software engineer, whether you're doing, back end, front end, machine learning, anything like that. So if you're feeling like you're in a good headspace to continue this workshop, we're going to take the Git and GitHub fundamentals that we built in the last video and now extend them to Python. Well, Python package management. So the tricky thing about Python is that there are a lot of different tools and functions and libraries that you need to set up. And especially in machine learning, they all conflict with each other and like just break everything. So before we can learn Python, run Python code locally is on our laptops, we need to be able to fix that problem. That's what we're going to talk about today. So if you go to this link, it's again in the description, you can go to setup Python, this file, and it gives you a bunch of details. If you're on Windows or Linux, then you can simply install these things by running this command here. I'm on Windows, so I'm going to do this, WSL. And if you're on Mac OS, then you instead run this. So let me just copy this here. All of these things are more or less already installed, so that didn't take much time. To test that your installation was successful, run these commands. So again, Python 3 is a command. You can use the version flag to see if you get a version. It doesn't need to be my version. It just needs to be a version. And this also, it should give you back some kind of message. By the way, whenever you see stuff like this, so this is just a file path telling you where this tool, this command was installed. All of these commands, they need to be installed on your computer on some file path. Now, this is a very generic file path. Every project you work on could, in theory, install files here. This is part of the problem that we need to solve with Python. If we try installing Python libraries and they all end up in the same place, one project could require a different version of a library, and then you have, two different libraries, different versions in the same place. They're stored in the same folders. That's not going to work. So that's the problem that we need to solve. Anyways, once you've installed Python, what I'm just going to mention to you is that Python 3, this command, is, it's just like any of the other commands that we learned in the very first video or workshop. So with the -c flag, we can give it literal commands. So for example, I can do 1 + 1, and that won't print anything because in Python we need to use something called a print function. We're going to learn about this soon. But if I do this now I get back to. So if you wanted, I mean, hey, we're coding in Python, but not really. So there's a bunch of setup work to do. So the things that we just installed, let me describe them. We installed three things. Python 3, I just showed you. It's a thing, a tool, a command that lets us run Python code. Usually we're not going to be running it like this. We're going to find a better way to do it. Pip is the Python package manager. It downloads tools from Pypi. That's the Python package index. This is where developers can upload their tools, their software, their code for you to download and use in your own projects. So for instance, there's a library called requests. You can use the request library to make web requests, interact with web browsers, a little bit like the curl library that we learned about earlier in the very first lesson. So requests can do this same type of thing that curl can. But instead of installing curl with apt, so sudo apt install or brew install, we need to use pip the Python package manager to install libraries like this on the Python package index. So just before you try running this command, I want to talk again about that issue. If we just run this command here without doing anything, what's going to happen is it's going to try installing this software to one specific folder, and it's going to try and break a lot of things, okay? Because if you install this version of requests, today, and then maybe a month from now you install a different version of requests, and they're all going to the same folder, well, you're going to have some problems. Like you can't have different versions in the same folder, and things are going to start breaking. So don't just run this quite yet, but this is what pip does. It's like, apt or brew. You can use it to install stuff, just, Python specific stuff. Now, the other thing that we installed is virtual environment, okay? This is a Python tool that can help us create what we call virtual environments. What are virtual environments? Those are our way to fix how do we install stuff without it all going to the same folder. So what a virtual environment does is when you install it, um, it basically creates a folder, a special folder inside of the current folder you're in. It creates a special folder where you can download stuff. Just download stuff from pip in particular. All of the software you download gets put in that folder. When you're done with your project, you can delete that folder, and then there are no conflicts. If all the tools you're downloading, they don't go to some folder like we saw earlier, if they're not going all to the same folder, like a folder like this, it's not going to exactly be this, but whatever, then we're not going to have the problem of different packages with different versions ending up in one folder. Because what we're going to do with this virtual environment manager is we're going to create a special folder for everything to go in for each new project that we start. So let me show you how to use this. It has 3 steps. It's, they're not intuitive steps, but what can you do? So the first step is this. We need to use Python 3, that command, -m for a module. A module is just a special word for, this tool. It's a Pythonic tool that we're using. And then we specify a folder name. This could be anything you wanted, you could have a folder named Bob, but often you'll want to create a folder named .benv, just a standard thing that you can do. So if I do this, seemingly not much is going to happen, seems like the same thing, right? But if I run ls-a, you're going to see I have a new .benv folder. The dot is just, it's a config folder. It doesn't have code that we're writing. It's just a convention to hide away some files that are just for setup purposes, okay? So anyways, when we ran this first command, you're going to need to, well, memorize it, but you're going to get familiar with it over time. What it did was it used the venv module, a part of Python, gave it a file name, a folder name, and it created a folder where we can install files. That's the first step. The folder where we want to install files to has been created. The second step is that we actually need to tell Python, okay, I created a folder for you to use, now go ahead and use it. The way that we do that is we do this. This seems mysterious and magical. For a second, just trust me and run it. You will see .benv here, and that's how you know that Python is ready to install files, tools, things just to that folder alone, and not mess up different versions being in different folders, okay? So if you want to get out of a folder, you want to switch over to a different project, you could do deactivate, and then again, you could do source dot to, enter a different virtual environment. Just for the sake of demonstration, I will show you how to do that later. But for now, I want to explain what is this thing doing. It's a little bit complicated. I have to admit it is a little bit complicated, so pay attention here. So the .venv folder, again, it is just a folder. If I do ls, you can see ls-a, you can see it's a folder over here. If I do ls-a.venv, then I can look inside of the folder, And you can see I have some different folders, including a folder named -bin. That's what we see whenever we have these slashes. It's like you have a new nested folder going on. So .venv is one folder, then you have bin after a slash means there's a bin folder inside this folder. Given that, we should also expect an activate folder inside the bin folder. Let's see if we have that. So ls-bin, let's look at inside this folder. And yes, indeed, we have a activate file, not a folder, but yeah, you can have these slashes separate files as well. Anyways, so we're doing source and then .bin bin activate. So we're looking for a file named activate. This file, it's inside the bin folder, which itself is inside the .venv folder. Just to help you guys see this, I have a special command called tree. You can sudo apt install tree or brew install tree. I have it installed, so I'm just going to do tree.venv. If you run that, it's going to look very messy, so I'm going to do -l to tell it only give me like 4 levels, L for levels. And you can see .venv, I have the bin folder inside that, and then I have the activate file inside that. Okay? So seemingly, when we were running this command, what was happening was, source is something, and then this is some file. So what source does is it runs a bunch of code. It's not Python code, but it is code. It's complicated code. So if I do nano activate, I can try and enter this file. Of course, I'm forgetting .venv bin activate. That's where this file is located. Folder 1, 2, and then this file. You can see a bunch of very complicated code here. Okay, I'm not gonna lie, it's complicated. What this is doing is a bunch of fancy stuff so that we're telling Python, you need to do a bunch of changes so that we can install files in this venv folder that we just created, this virtual environment. Again, lots of stuff, hard to understand, but I hope it is giving you just a little bit of idea as to why we're running these 3 commands. I'm going to press Control X to exit here. When we're creating a place, a local place to install files such that they go into one folder per project, not the same folder across all projects and mess everything up, what we need to do is we need to do python 3 -m venv and then give it a file name. Just for, change's sake, I'm going to say project A. That's a valid file, like a folder name. When I run this command, it's going to create a folder for pip to install things in. So I can see here, I have a project A folder, or you can call it, you can see my other folder, .venv. So both different folders that pip can use to install stuff in. Then I need to run source, the folder, then bin, and activate. So this could be, .venv, it could be project A, it could be whatever you decide your name to be. This is going to run a bunch of complicated code that we just saw, changes a bunch of things, but net result is you will see this pop up here, the name of your folder, telling you that whenever you install Python packages, they're going to go inside of this folder, not in one place across your computer, messing everything up. When you're ready to get out, let's say change to a different project, I could deactivate this virtual environment, this file, this folder where we're going to put all of our installations, and I could enter the other virtual environment that I created, let's say for a different project. Now I have a new virtual environment. Hopefully that's getting you the idea of how virtual environments work. They create these locations for us to install our files into to prevent conflicts between different versions of the tools we're installing. Just so that you see some conclusion here, I will indeed try and install requests, which is this module that does a similar thing to curl. So I do pip install requests. I had it installed already, that's why this didn't take much time. But because I see this, I know that request was installed into this folder. It won't conflict with other stuff. I can do pip list to see what I have installed, and you can see I have requests this specific version installed. Now, one last thing I'm going to tell you guys about pip is that usually you're not just doing pip install and then one file. The entire point of this is we're very precisely able to download which files we need, which Python, modules, packages, libraries, published pieces of code to reuse, which of those we need. So usually what we do is someone will give us a specific list of packages to install, and we install those. So I'm going to show you as an example here. Let's find a file. Let's see. I don't think I have one in this intro Python one, so let's move forward to maybe a ML focused workshop. Go back here, and you can see it here. So requirements.txt file. What this does is it names different packages, and then it specifies, okay, you must have a version of the package greater than or equal to this version and less than to another version. So you can use these files to very specifically download the versions of packages you need, not, just whatever version of package happens to be the latest on the Python package index, if that makes sense. Again, this can feel complicated, which is why Kaggle is good. It takes care of all of this installation for you. It just gets all the right package versions working together, and then you're off to the races. You can just program. But as a Python developer, you have to access packages yourself. So just for the sake of demonstration, I'm going to create a quick requirements.txt file just to show you. Let's say I want to install pandas, and I'll do the same thing that they did here. So greater than, version 1.5, less than version 3. So, this latest version should be fine. Let me just delete this. Control S, Control X. Just the last command for you. If you're installing stuff from a requirements file, so as you can see, I have this requirements file here. You need the R flag for a requirements file. So pip install -r requirements.txt. By the way, this may also be called pip3. It's just, yeah, you'll get used to it. A long time ago, there used to be a pip2 versus pip3 or Python 2 versus Python 3, but these days everyone's just using this, so whatever. We have some old infrastructure left around, and as you can see, it installed this latest version because it met my requirements. Let's say I wanted to change my requirements, actually. That's a good example for you to wrap up. So let's say I do, okay, like greater than 1.5 is fine, but I want it to be less than 2.1. Okay, Control S to save, Control X. If I run that again, pip install -r requirements.txt, well, now it's going to uninstall the last version. It's going to get a new version that satisfies my requirements, and it's going to change things around. So I hope you can see how virtual environments and these requirements.txt files can help you download precisely what tools you need so that you get working code every time. You don't have random problems come up. With that being said, we're finally ready to program in Python, so I'll see you in the next workshop to do so.